Hello YouTube. So I'm often asked about what are vectors? What vectors are they? Like how we can see them in actuality? Are they real? Do they exist? Do they always are they always on in our textbooks? You know, how can we see vectors? Whereas scalars they're pretty straightforward. We've seen them since we remember ourselves probably. We know that one apple plus another apple gives us two apples, and no matter how many, where these apples are, whether they are on a table or in the air somewhere falling down or whatever, we're gonna be having 1 plus 1 apple gives us 2. But there are creatures like vectors, and these creatures are basically they are real, and now I'm going to be introducing to you a bunch of examples where you can actually see where these, you can actually see them in actuality, and you can relate to them in real life, since these scalars are the parameters or the quantities that are really something that we are so used to, whereas vectors are not as much. So knowing about scalars, we know how to add them, we know how to subtract them from one another, and it's just something that we are so used to. For example, when I say, well, I'm 130 pounds, I go to a vacation and I gain 5 pounds, that my current weight is going to be 135 after I come from vacation. So scale, we are our lives is blended with dealing with scalars at all the time. But there are quantities in nature, and these are real as well, and these are actually vectors. So let's just give you a scenario on how these vectors are seen in real life. Suppose I have a car. And my car is now getting a flat tire. So I have a flat tire in my car, and suppose we live in a world where we don't have any common sense. So it looks really funny to think about. It sounds very funny to think about, but suppose we live in a world where there is no common sense. So when I get this flat tire in my car, I ask for some help, because I have to ask people to help me move the car. So there are two nice guys to come over to help me. Like I said, we live in a world where there is no common sense, so people actually try whatever they think could result in my car being moved to some other place so that I can get it fixed. So we try all possible scenarios. One of the scenarios that these guys can possibly come up with is to push my car in these two directions, and basically just push the car so that this car eventually moves somewhere else so that I can get the tire fixed up. They do this. I'm not going to reveal the result. You probably know the result, but hold on to it, and let's think about another scenario, because like I said, we live in a world where there is no common sense. So let's just give all the options a try. I mean, there are a billion options, but to be fast and straightforward with everything, let's just try just 2 options, and then we can go from there probably. So the other option would be the 2 nice guys who are coming over to help me out, to go to one side of my car, rear of my car, and just push it in one direction. So now we have 2 different results because of these 2 guys basically pushing my car in 2 different ways. Let's now reveal the results. Most likely, this scenario is going to result in my car being moved to somewhere else, whereas this one is not going to be helping me moving my car. So this just shows that no matter although basically these two guys are trying their best in both scenarios and they're pushing with the same amount in two scenarios, because this quantity, the pushing force, it's the direction of it matters. It really affects the result. So we know for this one, my car most likely is not going to be moving. For this one, most likely this is going to be moved, and then I can just get it fixed up. So as you see, this, and you know it by now, let's just move to our own world where we have actually common sense. So due to our everyday life experiences, we know there are some quantities, and these quantities are real. So there are some quantities that their direction matters. So what happens is that these two guys, if they push opposite to one another, this is not going to be moving. But for this one, when they push in the same direction, because in both scenarios, the pushing force is adding up, but because the directions are different, they add up differently and give results to different results. So this is one of those scenarios where vectors are in place. So basically, where vectors are involved. There is another scenario. We know all the time that, whenever, suppose that you're driving on a highway and then you're driving by, like, let's say 60 miles per hour. Then you call your friend and you tell her or tell him that, well, hey, I'm driving by, and the highway is pretty nice, and there is pretty much no traffic on the highway. I'm driving by 60 miles an hour or 70 miles an hour, however much was the maximum, speed limit of the highway. So you're telling your friend this information, but you know that please give it a try. It's just inevitable. Like, people right away will ask you where you are heading. Where are you going? Sure, you're going with 60 miles an hour per hour. You're going by 70 miles per hour, but where are you heading? So this information of the size of the vector, namely the 60 miles per hour or however much it was, is not complete for in terms of in terms of velocity. So velocity, or as we know it in real life, speed, is something that has both magnitude and direction. So what happens is that if you don't say where are you coming to the mall, are you coming to my place to get me, are you going to the mall, are you going to school? So all these are scenarios that you're going to be asked about when you tell the person your speed on the speedometer in your car. So yes, vectors are real. They are not just in textbooks so that you're gonna be bothered by them. They are real, and they basically, we use them every day. We don't notice them as much because we the things that we mostly deal with are scalars, but it doesn't mean that these guys don't exist. Vectors definitely exist, and I really want you to be comfortable with their existence. Don't think these are just on paper and they're there to bug you and like make you uncomfortable in terms of getting grades and all that sort of stuff. So next video, what I'm trying to do is I'm trying to get into how we are adding vectors, how we subtract vectors from one another, and basically how do they relate to everyday life experiences. So stay tuned for that. Take care. Bye now. Bye-bye.